Welcome to this explainer. Today, we're breaking down the urgent realities of Tropical Storm Bertha. We're going to look at the hard meteorological data, for sure, but we're also doing something a little bit different. We're pulling back the curtain on the technology and the journalism behind the scenes. When a major weather event strikes, getting accurate information out quickly can literally be a matter of life and death. So how do modern newsrooms actually process all this critical data so incredibly fast? Well, that's exactly what we're going to uncover today.
Okay, let's dive right in with a pretty crucial number, 60. That represents 60 miles per hour, which was the absolute maximum wind speed recorded when Bertha made landfall in southeastern Louisiana earlier today, July 22nd. When meteorologists look at a storm like this, that peak intensity is the baseline they use to gauge the immediate threat level to coastal communities. At 60 miles per hour, you're dealing with significant force, enough to cause real structural damage and severe disruptions.
But as we know, a storm's life cycle is highly dynamic. Since making that initial landfall, surface observations are showing us that the storm's center has actually become a lot less defined. It kind of flipped a little southwestward, hugging the South Louisiana coast. What we're seeing right now is that the current sustained winds have dropped to 45 miles per hour. Interestingly, though, most of the deep convection, that really intense thunderstorm activity, remains out over the northern Gulf waters just south and southwest of the center. Now check out how rapidly Bertha escalated and then de-escalated over a super compressed time frame. Back on July 21st, we were looking at 40 miles per hour. Then, within just 24 hours, it spiked to that peak of 60 miles per hour right before landfall. And as we track the data forward into today, it's already dropped to 45, with forecasts predicting it'll weaken further to about 30 miles per hour as we head toward Friday. Tracking this timeline is absolutely essential for emergency management and really for anyone living in the storm's path.
So you might be wondering, why is it weakening so quickly? Well, significant re-strengthening over the Gulf waters is actually pretty unlikely right now. The storm is essentially battling two major environmental factors: a dry mid-level air mass and strong, persistent north-northeasterly vertical wind shear. These forces are basically tearing at the storm, inhibiting all that deep convection we just talked about, and keeping its overall cloud pattern elongated and highly disorganized. It's a great reminder of just how fragile a storm structure can be when the atmospheric conditions turn against it.
Okay, so the crucial point here is Bertha's trajectory. What is steering this massive system? Right now, it's being driven by a large and strong mid-tropospheric anticyclone, basically a huge high-pressure area parked right over the south-central United States. Bertha is moving west along the southern edge of the system. Current forecasts expect the storm to briefly re-emerge over the northwestern Gulf waters on Thursday before making a second inland push, this time crossing the upper Texas coast. Which brings us to the immediate, localized impacts. Even though the storm is weakening, the threat is definitely not over. These active warnings from the National Hurricane Center highlight some very real ongoing dangers. We've got a coastal flood warning in effect for the Mississippi and Louisiana coastlines, where moderate coastal flooding is expected. Tropical storm conditions are spreading westward, impacting areas like Metro New Orleans and pushing toward the upper Texas coast. On top of all that, isolated flash flooding remains a major concern through Thursday night.
Section 2. The Tech. Speeding up weather news.
So, in the middle of a shifting, active crisis like Bertha, how exactly do newsrooms process all this complex data so fast? Well, for decades, companies like Weather News supplied broadcast scripts to over 100 TV and radio stations entirely by hand. But as you can imagine, manual scripting is totally prone to human error and massive bottlenecks, especially during severe weather events when updates are just pouring in by the minute. Enter the AI-powered Weather Script Agent, which recently launched in trial operations. It literally eliminates those human bottlenecks, generating broadcast scripts instantly with just one click, using the absolute latest forecast data.
But here is the absolute genius part. It's not just some mysterious black box of artificial intelligence. Transparency is built directly into the system. Broadcasters who might have zero specialized weather knowledge can easily use this interface. They can literally compare the generated script with the raw, actual forecast data side by side. This allows teams to quickly verify the facts and catch any weird discrepancies before they ever go on air to the public.
Now, how do you actually make an AI sound like a seasoned meteorologist? Well, the developers created something they call the ultimate instruction. The operations team at Weather News took 40 years of accumulated unspoken forecasting expertise, that tacit gut feeling knowledge, and translated it into clear, customizable rules for the AI.
They basically taught the machine to capture real human conditions. It doesn't just read out numbers. It knows how to convey nuances, like distinguishing when rain is just starting or when snow feels heavy and wet. It is such a fascinating merger of human experience and machine efficiency.
Section 3. The Newsroom. Delivering the context.
Having all this massive, high-speed data is one thing, right? But it really takes independent newsrooms to turn it into actionable journalism. As the independent news platform The Londoner notes, local reporting is the bedrock of a healthy city. Outlets like this utilize rapid updates to prioritize evidence, context, and civic accountability over cheap sensationalism. When a storm hits, people don't just need raw data. They need to know what it means for their specific neighborhoods, their public services, and their commute. Essential local reporting is what actually keeps populations safe, informed, and prepared.
The Londoner operates on 3 core editorial pillars that show exactly why a hyperlocal focus is so vital. First, they maintain unbiased independence, keeping editorial decisions totally separate from commercial pressures or party politics. Second, their hyperlocal focus is built directly around communities and public services. And third, they ensure public accountability by actively examining civic governance. In the context of severe weather, this structured approach is what bridges the gap between a massive, macro-level weather model and the everyday, on-the-ground reality of local residents.
So, if you want the most accurate, independent live news on breaking stories and to see a real-world example of this kind of journalism in action regarding Bertha, I highly recommend checking out their detailed coverage at londoner.news/tropical-storm-bertha-hurricane. And for ongoing, independent live news coverage on the events shaping your community, make sure you visit londoner.news to stay connected and informed.
I'll leave you with this final thought to ponder. We're standing at a pretty fascinating intersection right now. As AI completely changes the speed and efficiency at which we track massive storms and process global data, how will independent, hyperlocal newsrooms continue to shape our real-world understanding of the next major crisis? Technology gives us the speed for sure, but local journalism gives us the meaning. Thank you so much for joining this explainer. Stay safe out there and keep seeking out the facts.